Okay, so here we are with my 450 build, and as you can probably see, those of you who are familiar with the DJI 450, I haven't got the original plate at the top. I've made my own. This here is the original plate, and there's nothing wrong with it at all, except I wanted to put my flight controller inside between the two frames. For two reasons really. One, to give it crash protection, because I'm trying to develop a cheap model as an introductory model that people can easily assemble and gives them some guidance into best forms of crash protection. So I had designed a unit that would sit on top of the board, where my chosen controller, the KT2 or the Naze 30 board, would sit on top with a crash cage, but that was still prone to damage if you crashed it and it fell upside down. So I sat down and designed this new board here to allow the flight controller to be inserted between the two frames on some anti-vibration mounts. So it's unscrewed at the moment because I'm going to take it apart for you. I'm just going to give you a run through around the board. So here we've got 4 anti-vibration mounts which take the suspended flight control board. These cutouts here are cutouts just to save weight around the arms. Also, you've got the standard 4 holes to bolt the arms on. Standard cutouts here, pretty much following the standard plate arrangement, except on this section here I've had to divide the holes to give me an extra 3mm mounting hole, because you will notice, if I just zoom in a little bit, you will notice that there's additional 3mm holes scattered around the board. So if you wanted to install some form of standard additional board with either 45mm or 30.5mm spacings, they would connect straight onto the board. The only drawback is that the 45-degree board, the 45mm board, which would go in those 4 holes, they actually get blocked by the arms, so you would only be able to mount the board at a 45-degree angle. You wouldn't be able to get the board square. So if this was the board, I was trying to mount, sorry, just to zoom out for you. So if this was the board you was trying to mount a 45-degree spacing holes, I couldn't mount it like that because the mounting holes would go through the arms. You could only mount it in that orientation, which is 45 degrees, which shouldn't really be a problem. The only thing you've got to make sure that if you're using that to mount a flight control board, you've got to make sure the flight control board is pointing in the direction to the front of your model. So those of you with eagle eyes have also noticed these things here, and what these are for an easy way to mount a battery. When I was testing this mount and configuring the KK2 board, my battery was top mounted, and I found it easier to use rubber bands to put the motors to the battery on top of the board and remove it so I could see inside the screen. So obviously this viewing window allows you to see the screen. So I will just go and get a battery and I'll just demonstrate that to you. So here we are, I'm back with the battery. So the way I was installing my batteries, because I was taking it off, a quick hover, come down, adjust the PI settings of the board, and I was initially using Velcro straps, but I found them very, very laborious to use, so I came up with this idea. So the battery would go on the board, and the way, when it's top mounted, the battery actually sits on the rubbers, and it makes the battery very difficult to move because the battery is now gripping on rubbers. If you've ever tried to put a battery on a normal PCB, you'll find it will slip off, but because the battery is less than rub, it's very easy. Then all you do is you pop pop the rubber bands on. And obviously remember my board is not, my top plate is not fitted at the moment because I'm taking it off to show you guys in a minute. Top plate there, and that's it, job done. And that is very, very secure. I mean, that is not moving anywhere, and it just was a lot easier to keep flicking the rubber bands on and off to look inside the KK2 board. Moving on from that, I will just turn it over. The top plate shouldn't fall off, so I will just turn this over. And what I've done now, I've actually made some brackets now to allow you to do the rubber band mounting on the bottom. So the battery can fit on the bottom. Same idea. Oops. Same idea. Now you can just put the rubber bands across, and that's it. It's secure. The reason I was doing it, I'm checking what difference to the flight characteristics does having the battery on the top, which gives you a higher centre of gravity, and the battery on the bottom, which gives you obviously a lower centre of gravity. So that's the reason why I'm experimenting with the rubber bands, because it's easier to install and change batteries. At the moment I'm just using a 3-cell. I have tested with a 4-cell. So that's that. The other thing that I'm experimenting on here is, let me just move this for you, is a mobius mount here. So this mobius mount connects directly onto the base plate of the 450, no drilling required. There's 4 fixings to it. Turn it around. So that is the top ways. You can see there's some nylon fixings there, top plate, some anti-vibration mounts, and the mobius again will just bolt onto the bottom, again using rubber bands, but I'm going to cover that in another video. So that's what I've been doing with my 450. I did experience some problems just yesterday where a motor seemed to be lagging behind all the others when on the initial spool up, and it became more apparent when I changed from a 3-cell up to a 4-cell battery. It became very, very clear that one motor was just lagging behind. So I've desoldered it all this morning. I checked the capacitance through the motor windings and they were fine. I've just changed the ESC, recalibrated it, and the motor spins up exactly the same speed as all the others. So I'm pretty certain that it wasn't a bad calibration setup. I think it was just a poor ESC. So what I'm going to do now, I'm going to take the top plate off this board so I can show you how the KK2 board or an ACE32 or any ball with those spacings can fit onto this frame. So here we are. I've now just taken off the top plate. You can see that the receiver is still connected and on all the ESC wires. So here are the 4 rubber bobbins. The rubber bobbins then are connected to a plate, and this plate allows you to install different flight controllers. Then then you've got 4 pillars which connect onto the flight control board. So this flight control board is suspended on silicon mountings, and it just takes vibration away from the sensors on the board and makes them work less. I haven't compared my PID settings to other people's yet, because of my ESC problem I'm still tuning the board, but I will post those so you can compare them to what you're using. And it's very easy to put this back in. Let me zoom out, although it is easier if you took one of the arms off, because of these extra pieces here and here, which allow you to rotate the board round into the 45-degree rotation. These just catch on the edge of the arms, so you just got to sort of put it in and twist it. If one arm was missing, then you can slot it in from the side, twist it and do it up. So my forward direction is forward on the board here. Now, all boards will have a direction arrow. My white arms are forward, and obviously where my mobius mount is forward. So I'm just going to reinstall this to show that it is possible. Harder to do while you're on camera, obviously. And there you have it, that's back in. Obviously I just got to put the screw terminals back in, then I'll be ready to fly again. So I hope you found that interesting. I am going to do some more videos on, people may have seen that I've got colour-coded legs. So I make legs in 3 different sizes. So this is black FR4, this is white FR4, white nylon fixings, black nylon fixings, and those with red arms, you can have a red leg with red fixings. It's all nicely colour coordinated. I also have very thin cable ties, black, red and white also, and I believe they're 300mm long, so they were very hard to find, but sometimes having that extra length, generally they're only 150mm long, where the 300mm ones, you know, have got me out of a sticky situation now and again. So that's the legs, and I'll be doing another video on the legs to show you what height they give you off the ground. The reason I'm using extended legs is because the mobius mount sticks below the bottom. The mobius is going to be stuck on here, and there's also a crash cage that goes around the mobius, so it's quite well protected. So with these legs, it keeps the mobius off the ground, and the mobius mount is so designed so you don't see the legs or the propellers. These are 10-inch propellers, you don't see those in the frame, and that was the sole reason for designing it, as I personally don't like to see the propellers and especially the legs in the frame. Anyway, I'll be doing some more follow-up videos very shortly, so stay tuned. My next major project will be building a DJI 550 using the APM flight controller 2.6 and connected together with the Taranis receiver. I've only just taken delivery of all of that, so that will be my next build once I've finished tweaking this design. So keep checking on my channel, and please subscribe, give it a thumbs up if you found it useful, and also if you'd like to post any comments, that if you're struggling to mount products on your helicopters or drones, you need some brackets for your FPV equipment, just drop me a line, and you know, I can manufacture these things really easy. Say in-house CAD design, in-house CNC cutting, so it's a very quick turnaround service, and if you can provide your design on a PDF or DXF file, if you're into CAD, that's even easier. So please drop me some comments, tell me what you think, and if you need any products made for your builds, then I'm sure I can accommodate what you want. So that's Andy now signing out, and happy flying.